Okay, which point on the graph of y is equal to the square root of x, so just the parent function, is closest to the point? Well, this is also going to be an optimization. Closest to the point means we're minimizing distance. So there'll be a distance formula involved. So this is what we're talking about. So we have this parent graph of a square root. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. But we have this point, 6, 0. I've got this dashed line right here at 6, 0. And where will this distance from this point to this graph, where will it be minimized? All right, so that's what it's asking. So the distance formula, remember, let's do it this way. The distance formula is the square root of x squared plus y squared. So we just have to figure out our x and y. Well, here's our x. All right, and then this height, well, that height is f of x. F of x is the square root of x. So y is the square root of x, and the x we can substitute. Remember, it's the distance. Well, that's x subtract 6 squared, right? And then once you know the distance, we can go ahead and remember we have to minimize this. So we first have to simplify this. So x subtract 6 squared, remember Pascal's triangle, it'll be x squared minus 12x plus 36. Well, the square root of x squared is just x. So negative 12x plus x is just negative 11x. And that's going to be, I'm going to put it to the 1/2 power, and we're going to simplify that. So now we have this to the 1/2 power. We can take the derivative, and it's going to be the chain rule. This 1/2 will come out in front, and then followed by this, and then we'll multiply it by the derivative of the inside function. So 1/2 times all of that original function to the negative 1/2 power multiplied by the derivative of the inside function, which is 2x minus 11. All right, so now we can rewrite this. Let me do this. Since that's the negative 1/2 power, we can rewrite this as 2x minus 11 over, there's the 2 in the denominator, x squared minus 11x plus 36. And now that's just to the square root, because 1/2 power is the same as the square root. I don't know if you can see that very well. That's the derivative. We're going to set the derivative equal to 0. Well, when we set the derivative equal to 0, we're going to multiply both sides by this denominator. Well, 0 times anything is still 0. So now we have 0 is equal to 2x subtract 11. X should be 11/2. And I realize I already had some of that stuff, but yep, I rewrote it, then multiplied both sides by the denominator, giving us this. X is equal to 11/2. And so then, since y is equal to the square root of x, we just have to do this, the square root of 11/2, then we multiply top and bottom by the square root of 2 because we don't want to leave a radical in the denominator. So that distance, that's the shortest distance on this graph. So somewhere, wherever that is, that distance will be the square root of 22 over 2. And you could put that in your calculator and get the decimal approximation of that. All right, that's it.